Warahmatullahi wabarakatuh dan selamat sejahtera. So hari ini kita akan sambung dengan topik 3, lesson 1, topik 3, Avogadro's number and molar mass. So objective of our lesson today is to define mole in terms of mass of carbon-12 atoms and Avogadro's constant, and relative Avogadro number with molar mass and molar volume of gas at room condition and STP. So the first one is to define mole. Define mole in terms of carbon-12. So basically, based on mass of carbon-12 atom, 1 mole of particle will contain the same amount of particle as in 12 gram of carbon-12 atom. So for example, if we have a balloon that contains 1 mole gas, the amount of gas particle inside the balloon will be same as the amount of particle as in 12 gram of carbon-12 atom. Okay, amount of particle inside the 1 mole of gas is same as amount of particle in 12 gram of carbon-12 atom. So that is mole in terms of carbon-12, mass of carbon-12 atom. So 1 mole of particle will contain the same amount of particle as in 12 gram of carbon-12 atom. So the second definition, how to define mole in terms of Avogadro constant. So in terms of Avogadro constant, 1 mole of particle will contain 6.02 times 10 to the power of 23 particles. So therefore we know that if we have 12 gram carbon-12 atoms, okay, inside 12 gram of carbon-12 atom will contain 6.02 times 10 to the power of 23 carbon-12 atoms. Okay, inside 12 gram carbon-12 atom will contain 6.02 times 10 to the power of 23 carbon-12 atom. Okay, and then the second objective is to relate Avogadro's number with molar mass and volume. So what is molar mass and what is molar volume? So molar mass is a mass of 1 mole of substance. So unit used in molar mass is gram per mole. So for example, you have molar mass of carbon is equals to 12 gram per mole. This means that 1 mole of carbon will have mass 12 gram. Means that 6.02 times 10 to the power of 23 carbon atoms will give you mass as 12 gram. Okay, that is molar mass. Okay, another example, if you have a molar mass of hydrogen is 1 gram per mole. Means that mass of 1 mole of hydrogen is equivalent with 1 gram. Means that 6.02 times 10 to the power of 23 hydrogen atom will give you mass 1 gram. Okay, that is molar mass. So for molar volume is volume occupied by 1 mole of gaseous particle. So unit used for molar volume liter or dm cube, so decimeter cube. So there are two values of molar volume, depends on condition. So at STP the volume of 1 mole of gaseous particle is 22.4 liter. So in room condition 24 liter. Okay, so for example, if I have 1 mole of helium, so the volume of 1 mole of helium will be 22.4 liter at STP. Okay, or 24 liter at room condition. Okay, other than that, if you have 1 mole of hydrogen gas, okay, 1 mole of hydrogen gas will give you volume 22.4 liter at STP and 24 liter at room condition. So that is molar volume of 1 mole of gaseous particle, 1 mole. Okay, as long as your gas volume has 1 mole, has amount of 1 mole, the volume would be 22.4 liter at STP and 24 liter at room condition. Okay, and then we look at example. Okay, this example is on your notes on page 10. So refer to your notes on page 10. You will get this example. So how many glucose in C6H12O6 molecules are there in 5.23 gram of glucose? Okay, how to answer this question? First, it asks you to calculate number of molecules given to you, mass of glucose. So to know the number of molecules, you need to know the number of mole first. So to calculate number of mole, you will use mass given. Okay, so to calculate the number of mole from mass, you need to know the molar mass of glucose. Okay, molar mass of glucose is 180.0 gram per mole. This means that for 1 mole glucose will have mass 180 gram. So means that if you have 5.23 gram of glucose, so how many more glucose inside to 5.23 gram of glucose? So to calculate number of mole of glucose is equals to, so this one, we use for this one, we want to know the mole of glucose. So from right to left, from right to left, 180 to 1. How to convert 180 to 1? We need to divide by 180. So if above, divide by 180. So below, we need to divide also by 180. So you will get the formula 5.23 divided by 180. So you akan dapat mole 0.0291 mole. Okay, that is mole of glucose. So to calculate the number of molecules, we need to relate it with Avogadro constant. So to relate it with Avogadro constant, so we know that 1 mole of glucose will have 6.02 times 10 to the power of 23 glucose molecules. So if we have 0.0291 mole glucose, so how many glucose molecule? So the one that we want to calculate is on our right side. So from 1 to 6.02. So you need to times 6.02 times 10 to the power of 23. If above, you times with 6.02 times 10 to the power of 23. So below also you need to times with 6.02 times 10 to the power of 23. So you will get number of glucose molecule. You will get the formula 0.0291 times 6.02 times 10 to the power of 23. So the answer is 1.75 times 10 to the power of 22 molecules. Okay, that is your answer. Okay, now we look at example 2. Calculate. Okay, this example you may refer to your exercise book, page 19, question 6b. So calculate the number of molecule in 20 gram of water. So same as example 1. So first you need to determine, since that given mass of water, so it means that we need to relate molar mass to find the number of mole of molecule. So molar mass of water is equals to 18 gram per mole. So means that 1 mole water is equivalent with 18 gram. So if you have 20 gram of water, so how many mole water? So you will get the formula. So right now 18 to 1. So to convert 18 to 1, you need to divide by 18. So above divide 18, so below you also divide 18. Okay, so number of mole of water is equals to 20 divided by 18. So you will get 1.1 mole. Okay, so right now you have calculate the number of mole. So to convert to the number of molecule, you need to use Avogadro constant. So 1 mole of water is equivalent with 6.02 times 10 to the power of 23 water molecules. So right now you have 1.1 mole of water. So equivalent with how many water molecules? So right now 1 to become 6.02 means that you need to times with 6.02 times 10 to the power of 23. So below you also times with 6.02 times 10 to the power of 23. Therefore number of water molecules is equals to 1.1 times 6.02 times 10 to the power of 23. So you will get the answer 6.62 times 10 to the power of 23 molecules. Okay, now we look at the example 3. This one also in your exercise book, page 19, question 6c. So refer to your exercise book, page 19 and question 6c. Okay, the question: calculate the number of molecules in 75.0 liter of F2 gas at STP. So right now given to you the volume. So how to calculate this one? So means that you need to calculate the number of mole, you need to know the mole first. So to convert a volume into number of molecule, you need to relate it with molar volume. So we know that 1 mole F2 will have volume at STP 22.4 liter. Okay, right now we have 75.0 liter. So how many mole of F2? So to find mole of F2, so we need to 22.4 to 1 divided by 22.4. So means that 75. To calculate the number of mole, we also need to divide it by 22.4. So number of mole of F2 equals to 75.0 divided by 22.4 liter. So you will get the answer 3.35 mole. Okay, right now you have calculate the number of mole. Now convert it into number of molecules. So to convert to number of molecules, relate it with Avogadro constant. So 1 mole of F2 will have 6.02 times 10 to the power of 23 F2 molecules. Okay, so you ada 3.35 mole F2. So how many F2 molecule you have? Now 1, 2, 6.02. So means that times 10.6.02 23. So above times 6.02 means that below you need to times with 6.02 also. So number of F2 molecules is equals to 3.35 times 6.02 exponent 23. So you akan dapat 2.02 exponent 24 F2 molecules. Okay, so that's all for today. Assalamualaikum.